This is the second tutorial covering the 2DXY SlickMoves tools. This tutorial covers the object arrangement tools, which you see in front of you. There are 8 tools, 6 align tools: left, middle, right, top, center, and bottom, and 2 equally spacing tools in the X and the Y. You remember from our last tutorial that this is the second category of tools. The first were the object tools, and this tutorial covers the second category of tools. Scrolling down, we remember that the object tools act on each selected object in relation to its own local axis. So you could select multiple objects, but each one would be moved in relation to its own XY plane and the direction of its own axes. The arrangement tools are different than that. You can select multiple objects, but they are all moved parallel to a single active XY plane, but constrained by anchors. So I need to explain to you what the definition of this active XY plane is and what it means to be an anchor. It says here that the active XY plane can either be a gluing face, if you've selected an object glued to a face, or if not, you can just select a face, any face, to be the active XY plane. But if you do neither of these things, then the global XY plane is the default. The arrangement tools also control the movement based upon anchors, which I'll describe as I demonstrate them. So here we are in SketchUp, and I've put some objects in this arrangement to illustrate these concepts. We're going to begin assuming that the active XY plane is the global XY plane. We're not going to select any other plane as our active XY plane to begin with to illustrate these concepts. I can select any number of objects. I'll select this table, these 3 chairs, that bench, and I will demonstrate each of these tools in turn, followed by an undo. So if I select the align left, the objects all align with the leftmost object, which in this case was that bench. I'll undo that. I can align them all to the rightmost object, which is that chair, and undo that. I could align them with the topmost in the Y direction, which is again the bench, undo that, or the bottommost, which is any of these 3 chairs. You see there's a guide drawn each time to show you what the alignment position is. If I select the center or middle options, center and the X, it will find the midpoint between the 2 outside objects. So the objects will all be aligned to that point. And similarly in the Y. And undo that. So that shows all of the 6 align options in both directions for these selected objects. Now these objects all happen to be sitting on the global XY plane, but what I want you to understand is that the objects you can select can be literally anywhere. If I select this sofa, which is sitting up on a different story, and align to the top Y, all objects will be aligned to that sofa, and undo. Or if I align to the bottom Y, then the sofa is actually aligned. You see it here in midair above the chairs, which were previously in the minimum Y position. So that's the simplest case of alignment. Now, to illustrate equal spacing, again, it doesn't matter where the objects are, but I'll just select these same 5 objects. And you can either equal space in the X direction or the Y direction. So if I hit X direction, what it does is move these objects so that the space between them is the same. You can see in the measurement window here on the left, it tells you that there are 4 gaps, each at 35.45 inches. So this is a 35-inch gap, this is another one, this is another one, this is another one. So you know what the spacing is. What happened, of course, is that the 2 outside objects acted as anchors. They did not move. They defined the span of the equal spacing operation, and only the middle 3 moved. Let's just undo that and do it again. Now this time, every time you redo the equal spacing of the same type with the same selection, it uses the centers of each object as the equal spacing option. Sometimes when you equal space, you want to do a center to center equal spacing. So this shows that there are 4 center to center equal spaces of 82 inches between each of the 5 objects. Again, the 2 outside objects did not move at all, but you can toggle this button back and forth as often as you like to decide which of the 2 equal spacing options you want. Some software has the habit of asking you these things in advance which you want to do, but I prefer software that does the work and lets you choose. So if we instead do equal spacing in the Y, this is what you get. Here we have a very small gap in the Y, and if we hit it again, it'll switch to a equal spacing center to center. Again, the 2 outside objects, this chair and that bench, were the anchors. They didn't move. Let me just undo these to get us back where we were originally. And let me illustrate the use of a different type of anchor. So if you merely select objects like we did, the outside objects will become the anchors. But if we also select an edge, for example, then instead the endpoints of that edge will become the anchors. So in this case, if we hit left, all of the objects will align with the leftmost point on that edge. Undo that. If I hit the right, they'll all align with the rightmost, and undo that. Center, they all align with the center of that edge, and undo that. Similarly with the Y direction, they'll align with the largest Y of that edge, the endpoint in the most high in the Y direction. Undo, and similarly at the bottom, undo, middle, undo. Equal spacing, the same thing. Now instead of the 2 outside objects being the anchors, the endpoints of this line will be the anchors. So in the X, the endpoints are the anchors, and all 4 objects move. So that now we have 1, 2, 3, 4, and 5 equal spaces, which are the size of which is shown here. And we can toggle that to be equal spacing between centers. In this case, the desk is so large that it actually overlaps the end of the line, but its center to center spacing is what we're controlling here. So we have 5 spaces of equal size between these objects. I'm going to undo that. And the same thing with the Y, of course. Toggle that for the center to center, and undo, undo. To show you a different way of assigning anchors, we can select a guide. Here's a guide. As long as guides, of course, are infinite in length, the normal ones, so they can only be anchors if they are perpendicular to the direction of motion. So if I select these same 4 objects, or even 5, and select right, they'll all align to that guide. And if I select left, they'll align to it on the other side of it. But if I select a Y, that guide will be ignored. It's as if it wasn't selected at all, and we'd go back to the default of using only the objects. In this case, the topmost object in the Y was the bench, so that's how it aligned. So guides only work if they're perpendicular to the direction of motion, either the X or the Y. And if I pick this guide here and these objects, of course I can align them in the Y but not the X. There's a special case of object anchors where I'll illustrate by left justifying these 4 objects. Now, these 3 chairs and this table, if I equal space them in the X, you see that the table, because it is larger than the chairs and extends the entire, it becomes both the left and the right anchor, because it's larger than any of the chairs, and is both leftmost and rightmost. Then SlickMoves automatically uses it as a double anchor, I call it, and the spacing becomes only the chairs move, and these are the equal spaces between. Toggle again, and it switches to center spacing. Again, only the chairs move and not the table. I'm going to undo that. Get back where we were. The last example I'll show you, which is oftentimes quite useful, is to select a face. Now this face is on the XY plane, the global XY plane. Double click it so that its edges are selected. That means these edges, or the endpoints of these edges, become the anchor points. So again, if I select these 4 objects and right align them, they align with the rightmost point of all those edges. And I'm going to undo that, and left will be the leftmost point of all those edges. Undo that. Align the top. They align with the topmost point of all those edges. And bottom, they align with the bottommost. And similarly with equal spacing, both between the objects and center to center. So you see you have a rich set of options in selecting objects and the different kinds of anchor points, either the outside objects themselves, sometimes a double anchor object if it's larger and spans the entire selection, and any number of edges selected to define the overall extent, minimum and maximum X and Y. So far, all of our examples have used the global XY plane as the active plane, but any plane can be used in similar ways. And to understand how SketchUp defines planes that aren't horizontal to the global axis, it's interesting to see how it glues objects to planes. So if I select this skylight and move it onto this plane, you see it's automatically oriented so its y-axis is flows down the slope of this plane, and its x-axis is perpendicular to that and therefore parallel to the global XY plane. Similarly, here or here, it always puts the local y-axis flowing down the plane. And what this means is that even though, for example, this face is a rectangle, you might think that the orientation of the edges has something to do with its axes, but it doesn't. The axes are always defined as I've just described. And one way of seeing that also is to use the draw XY function, which works with faces as well as objects. And you can see this triangle has its edges aligned with the axes. This is the origin, this is the x-axis, y-axis, but this one does not. This shows the origin, this shows the direction of the x-axis, parallel to these. This shows the direction of the y-axis, parallel to, again, to the y-axis of the skylights. And once you understand that, you can now define planes other than a global XY as the active XY plane. The other thing you need to understand is that the tools for alignment and equal spacing are view dependent for when you use the global XY plane. So for example, these two skylights which I put on the ground, if I'm viewing them from this angle, then to top justify them, I'd use this button. And there it is. And I'm going to undo that. But if I'm looking at it from this point of view, I'm going to use the left button to do the same thing. So when objects are on the global XY plane, or when that's the active plane, the orientation of these buttons are view dependent. For other planes like vertical planes or sloping planes, the x direction is always perpendicular to the slope, the y direction is always with the slope, no matter how you're viewing it. So let's just demonstrate this. I've selected this plane and its edges for the anchors, and if I top justify it, bottom justify it, left justify it, right justify it, center justify, and center the other direction, it's all in relation to those axes. Similarly over here, right justify, undo, left justify. I forgot to select the edges here, so let's do that. Left justify to the edges, right justify to the edges, top justify, center justify, center, and bottom. So it's within this extent, and in the axis directions shown here by the draw XY function that control the motion for the arrangement tools. So let's proceed to a discussion of how we define planes other than the global XY plane as the active plane. There's two ways to to define the active XY plane. The first one is to select objects that happen to be glued to a face. In other words, so these windows, which I know are glued to this face and this door, if I select any objects, even if only one of the objects I pick is glued to a face, then that face is automatically going to be the active XY plane. And I can do all of the operations that we've already looked at on that plane. So I can top justify to the uppermost object, bottom justify, equal space between those objects, or I can double click on that plane, mainly just to select the edges for anchors. The fact that I've selected the face is superfluous because the gluing is going to govern the active plane. So I can bottom justify, I can equal space in relation to the edge anchors. Then if I go and select just the objects again, the gluing face alone defines the active XY plane, and top justify will put the windows at the top of the door, not at the top edge of the plane. Now, so the only caveat about this is that you can't select, if you select objects that are glued to two different gluing planes that aren't parallel, and try to justify them, you'll get an error message that says you have two non-parallel gluing faces. Try again. That's an error because I'm trying to avoid any situation where any of these commands will break the glue and move the object off of the plane it's glued to. You can select two objects that are glued to different planes as long as they're parallel to each other. And in this case, I want to align this window with this one with this one, and I can do that. But in order to get this one justified to the same level, I'll have to do something like select this guide, and the face that this window is glued to will be the active XY plane. The alignment will be to the Y level of that guide, and we've accomplished the same thing. So I'm not going to go through all the permutations of everything that we did on the global XY plane, but literally everything that I did on that in those examples, using edges, guides as anchors, double anchor objects as anchors, all can be done on any gluing plane, including, of course, slanted planes like this one, which, if I select these skylights, they're glued to this face, so I can align them to each other. I can equal space them amongst each other, but if I want to equal space them to the entire surface, I double click on the face and equal space them across the entire surface. Again, every other possibility is equally doable, as long as you pick at least one object glued to the face. So the second way of defining the active XY plane, if there isn't any glue involved, is just to select a face. You've seen in the demonstration how easy it is to select this floor and center in both directions this table. I can select this table and these chairs. Let me select the chairs first and align them to each other first. Then right justify with the table, then equally space, using a double anchor for the table. So that's all easy to do without any glue and without defining anything but the global XY plane, because we're moving things in the global X and Y direction. But what happens if we have a room that's at some angle like this? Well, the answer there is to use the walls as the active XY plane. So if I select this one, double click it to get the edges as the anchors, I can center this table. That's centering it vertically. I want to center it this way. It's already centered. I can align these chairs with each other. I don't want to select the edges in this case by doing that, or maybe that is better. Then selecting the table, top justifying, let's try that again. I want to select this face as the active XY plane, and the table and the chairs. Right justify, center justify. So by alternating between selecting this face and this face, you can accomplish the same thing as we did here using the floor. There may be cases where you don't have a face handy. So for example, this whole room could be, let's say, an object, a group, and you want to align these chairs in relation to that surface. So what I do in this case is I just draw a temporary rectangle face, select it, then select what other objects I want to align with it, and right justify like that. Once I've done all my alignment and arrangement, I can just double click on that face to delete it, and I've accomplished all the same thing. So again, two ways of defining the active XY plane, either by gluing, selecting an object that's glued, or just selecting the face itself. So just to review the main concepts here, the active XY plane will always be, number one, the face that any selected object is glued to. If there are no objects selected that are glued to a face, then if you select a single face, it can be the active XY plane. And if neither of these two things apply, then only then the global XY plane is the default. Anchors for the arrangement tools will always be the bounding endpoints of any selected edges or guides. And if no edges or guides are selected, then it will be the outside objects, extreme objects in local X or Y will become the anchors. And anchors never move. That's the end of this second tutorial. I'm considering doing another short tutorial on some other tips and tricks. So you might look out for that later, but thanks for watching and have a nice day.